All right, so 6.5 was all the proportionality theorems, right? Dealing with the parallel lines in a triangle like the first one, or 3 parallel lines being intersected by transversals like the second one, and then the angle bisector like number 3. So it says to find the value of the variable. Number 1, we know that if 2 parallel lines, or if there's a parallel line connecting the sides of a triangle, then it divides them into proportional segments. So this over this would equal this over this. I could go top, bottom, top, bottom. I could go left, right, left, right, right, left, right, left, bottom, top, bottom, top. Doesn't matter which order you do that in. I could do the top to the whole thing and top to the whole thing, whichever way it works. So probably easiest was 20 to 10 because that would reduce to 2 to 1. So then 2 over 1 equals x over 6. Cross multiply and you should get x equals 12. Questions on that one? All right, number 2 is now dealing with 3 parallel lines cut by 2 transversals. Again, these divide into proportional segments. So I can do x to 12 equals 18 to 16. I can do x to 18 equals 12 to 16, or the reverse of either of those. So I would say, it doesn't really matter, they're going to reduce either way. X to 12 would equal 18 over 16. This would reduce, because these are both divisible by 2, 9 and 8, and I get x over 12 equals 9 over 8, and then cross multiply, 8x equals 9 times 12, 108, and then x equals 108 over 8, which can be simplified to 54 over 4, again, 27 over 2. That's the most simplified fraction, or you can actually take and divide it. And I get 1/2, or 13.5. So any of those answers that are either a simplified fraction or an improper fraction or a decimal that terminates works. You don't want to do a decimal that you have to round. So if it was like a 0.3 repeated, you don't want to do that. You want to make it a mixed fraction. So we went a little easy on the quiz as far as that goes. Like I let you kind of round it, but that's not an exact value, so you don't want to be rounding it. Yep. All right, last one was your angle bisectors. So first of all, you had to have this piece of information that these angles are congruent, or they have to be marked here in order to know it's an angle bisector. Otherwise, none of it works. If there's a bisector of the angle, then it divides it, again, proportionally. So I could put 17 over 10 and y over 14. Or I can go left, right, left, right. I could put 17 over y equals 10 over 14, and that reduces. Okay, but it doesn't make it wrong the other way. So this would be 5/7, and I get 17 over y equals 5/7. 17 times 7 would equal 5 times y. 17 times 7. 119, and then divide both sides by 5. Thank you. So this is an answer. 5, 23, and 4/5. Yep, 4/5 is an answer, or 23.8 because it terminates is an answer. Questions on that one? So those are the 3 theorems in that section. And then this last question said, the diagram represents a tract of land being developed for homes. Which lot has the greatest perimeter? So if there's 3 lots there, you would need to know all 4 sides on each of them. So this is 40, that one's given to you. This is 80, that's 10, that's 130. All the vertical sort of ish ones are given to you. And then the bottom, 80, 20, 150 is given to you. What you don't know is the stuff at the top. So I can again say top to bottom, or because this is a whole thing here, I could line it up in certain parts. But you cannot, so this is where it gets tricky. If I'm going to use this segment, right, to this segment, then I have to treat it as though it's a triangle, and I have to use the part at the top to the, well, actually this one is 3, this is fine. I can cut this off. So I can say this to this would equal this to this, or the reverse, that to the top equals that to the top. So I didn't give you anything at the top, huh?
Yeah, you did. 85.
Oh, yeah, that's the one at the top. I'm missing it. So I can do 85 to 80. So I can do top to bottom equals B. Let's call it B because that's a lot B to 120. And then I could do 85 to 80 equals C to 150. There's a lot of other ways you could do it. You could do like that. What you can't do is like chunk it this way, right? Because that's not a triangle. The triangle would have to be like, you'd have to use it as though it's proportional triangles. So this would be 17 and 16. 17 over 16 equals B over 120. You could have also put 120 and 80 together. That might have been easier. 85 over B equals 80 over 120. Those cancel. That's 2/3. So 2B, 255, and then B would equal 1, 2, 7, and 1/2, or 127.5. And then same thing here. I could either do this, or I could group these two and these two together. So I can say 80 over 150 equals 85 over C. This cancels, and I get 8 over 15. Yeah.
Why did you put the B on the next one under where the 7 comes? Why are you showing different ways to do it? Different ways.
It's just because you can simplify it with those numbers, maybe easier. If not, you can keep it as 17 over 16. It would be the same. Yeah, you should get the same answer either way. So this is 15. And then I'd have to divide by 8. As long as it's reduced, yeah, which I think that's reduced. Yep. Mm-hmm. So either one of those would have worked. Lewis.
On test, if it's irrational, or if it's repeating, could we just like write it?
No, you're not going to write repeating. You're going to leave it exact. So by putting that little bar over it, it's not an exact answer anymore. So you can either leave it improper, or you can put it as a mixed number. But you don't want to use a decimal unless it terminates. So like if it's 0.25, that's fine. But if it continues like 0.3333, then you don't want to use that answer. It's no longer accurate. It's no longer exact. Forgot the whole point of the question was which one was bigger, right? So you have to add them all up. So this A was 130, 85, 80, and 110. Right? Did I do that? Yeah. That's 405. That's A. B was, where's B? 127.5, 110, 80, and 120. 10. 437, that's B. And then C was 157 and 3/8 plus 150 plus 40 plus 80. Or 29 and 3/8. So which one's the biggest? Okay, so this one you had to use like, so 10 to D would equal this whole side to this bottom side. So now you have to chunk it up as though it's a triangle. You could do it that way, which would be 25 to 12.5. Or you could go top to bottom and top to bottom. 12 to 15 would equal F to 10. So you could do it either way. If you go top to bottom, you can continue and do 12 to 15 would equal E to 5. And you could do 12 to 15 would equal 12.5 to C. God bless you. So you could do either way for the ones on the outside of your triangle. But the ones that are running this way, which are kind of like the bottom side of the triangles, you have to do this way. You have to say, let's say I use the bottom side. The bottom side of the small triangle to the left side of that small triangle would equal the bottom side of the bigger triangle, which is this whole thing, to the bottom side here. And then I have to follow that pattern. So then if I did this whole side, that'd be 30 to C would equal, so I'm going 30 to this bottom, would equal 25 to 12.5. And then the last one's the whole side. So whatever I get for B, which we found out was 15.625, you'd have to do this whole side to A. Or this whole side. It doesn't matter what side you use, but you have to use the whole thing.
So basically just turning into a bunch of triangles.
For these sides only. If it's the top side and the bottom side in this diagram, like the actual sides of the triangles, because these are parallel, I can go top to bottom, top to bottom, top to bottom. But as soon as I start to use those segments that connect the two sides of the triangle, you have to use part of the small triangle and then part of the bigger triangle and the bigger triangle and the bigger triangle. This is more complicated than what you'll see on your test. Maybe like half that, sure, but not like all those parts. Okay, so bell's about to ring. I did publish your chapter review. I would like for you to start it tonight. Do as much of it as you can so that when you come in tomorrow, you know what you know and don't know so that we can review a little bit more. But basically, it's what was on your quiz, which again, I'll give back to you tomorrow, which is all the starred 6-1 was just proportional polygons. So all of them. So this is where scale factor came from. Okay. Then 6-3, sorry, and 6-4 were angle, angle, side, 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 and side, angle, side similarity. So these might be single questions like, are they similar? If they are, what makes them similar? And your proof is also going to come from that section. And then 6-5 is literally what we just went over, all of those three theorems.